Hello students, I am Vijayalakshmi Pradhan. Today I am going to discuss the chapter Force and Motion. After completing this lesson, you will be able to explain the cause of motion, concept of force, distinguish between balanced and unbalanced forces, define the terms inertia, mass and momentum, state and explain the three laws of motion and explain their significance in daily life and nature, derive a relationship between force, mass and acceleration. You can also be able to explain the force of friction and analyze the factors on which it depends. You can illustrate and appreciate that rolling friction is less than sliding friction. Cite examples from everyday life where importance of friction can be appreciated. Explain the terms thrust and pressure, citing examples from daily life situations. If we place a ball on a flat surface, it will remain there unless we disturb it. It will move only when either we push it or pull it. This push or pull acting on an object is known as a force. What else happens when we apply a force on an object? Think. Let us do an activity to understand it. Hold an inflated balloon between your palms. Now apply a force on it by pressing your palms. What do you observe? You will observe that on pressing the balloon, its shape changes. Thus, we can say that on applying force, the shape of a body can be changed. Can you now think of some other effect of force? While playing football, if you want to change the direction of the moving ball, you will have to kick the ball in a particular direction. When you kick the ball, you apply certain force to change the direction of the moving ball. You can also change the speed of a moving object by applying force on it. For example, the speed of a moving bicycle can be changed by applying brakes on it. Thus, we can say that the force applied on an object can make the object move from rest, change the speed of a moving object, change the direction of motion of the object, change the shape of the object. Now, let us discuss about balanced and unbalanced forces. Have you seen a game of tug of war? In this game, when the two teams pull with equal force, they apply balanced forces on the rope. The rope thus remains stationary. When one of the teams applies greater force, it is able to pull the other team and the rope towards their side. In this case, forces are unbalanced. Let us perform an activity to understand this concept. Place a brick on a table, push the brick towards left with your right hand. What do you observe? The brick begins to move to the left direction. Now push the brick towards right with your left hand. In which direction the brick moves this time? It will move in right direction. Now push the brick from both sides with equal forces. What do you observe? In this case, you will observe that the brick does not move in any direction. Can you think why the brick does not move this time? In fact, in this case, the two forces balance each other. Such forces are called balance forces. What happens when the two opposite forces acting on the bricks are of different magnitudes? In this case, the brick would begin to move in the direction of greater force. Such forces are called unbalanced forces. Unbalanced forces acting on an object may change its state of rest or motion. Have you ever shaked the branches of a tree vigorously? The leaves and fruits get detached. Similarly, when you beat a carpet with a stick, you will see that the dust particles get detached from the carpet. Do you know why? The answer to all such questions is inertia. What is inertia? You can understand the property of inertia by doing a simple activity. Take a smooth sheet of paper and place it on a table with some part of it coming out of the edge of the table. Now place a glass half filled with water on the paper. Remove the paper with a jerk. What do you observe? You will find that the glass remains in its position. This inertia of the glass prevents it from moving with the paper. Thus, we can say that the inertia is the tendency of objects to stay at rest or to keep moving with the same velocity. You can find out some more examples of inertia from your daily life. In fact, it is the inertia due to which a sprinter keeps running for some time even after crossing the finish line. Similarly, you would have noticed that it is difficult to take out the tomato sauce from a bottle by just inverting it. However, it is easy to take out the sauce from the bottle by giving a sudden jerk to it. By moving the bottle in the downward direction, the sauce comes in motion. When the bottle stops suddenly, the sauce remains in motion due to inertia of motion and comes out of the bottle. By now, you have learned that due to inertia, an object offers resistance to change its state of motion. Do all objects, massive or lighter, have the same inertia? Let us find out. Push an empty box on a smooth surface. Now, try to push a similar box full of books on the same surface. What do you find? Why is it easier to push an empty box than a box full of books? Now, suppose you are asked to stop a tennis ball and a cricket ball moving with the same velocity. On which ball you are supposed to apply more force to stop it? You will find that cricket ball requires more force to stop as compared to table tennis ball. Thus, all objects do not resist a change in their state of rest or motion equally. Massive objects resist more than lighter ones. What do you conclude from these observations? We can say that mass is a measure of inertia. You have learned that an object offers resistance to change in its state of motion. This was studied by Newton in detail, and he presented his findings in the form of 3 fundamental laws that govern the motion of objects. Newton's first law of motion is stated as follows. Every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by some unbalanced forces to change that state. Newton's first law of motion tells us that all bodies resist a change in their state of motion. We know that this property of bodies is called inertia. That is why Newton's first law of motion is also known as the law of inertia. First law of motion has many applications in our daily life. Why do the passengers standing in a bus fall in the backward direction when the stationary bus begins to move suddenly? This observation can be explained on the basis of first law of motion. The feet of passengers are in contact with the bus. When the bus starts suddenly, the feet starts moving with the bus, but the upper part of the passenger tries to remain at rest due to inertia and tends to fall in the backward direction. What happens when the moving bus stops suddenly? In this case, the passengers standing in the bus fall in the forward direction. Can you think the reason of it on the basis of the explanation of the above example? Let us discuss about momentum. You have learned in the earlier section that the force required to stop a moving body depends upon its mass. Now suppose two balls of same mass are moving with different velocities. Which ball will need more force to stop? You will find that the faster moving ball requires more force to stop it. Thus, the force required to stop a body also depend upon its velocity. You must have noticed that a small bullet when fired from a gun can kill a person, but the same bullet if thrown with hand can hardly do any harm. Similarly, a truck parked along a roadside does not require any attention, but a moving truck may kill a person standing in its path. Is it only the velocity of the truck which makes us frightened? If it is so, then a toy car moving with the same velocity as the truck would have equally frightened to us. From these observations, it appears that the impact produced by the objects depend on their mass and velocity. These two quantities help us to define a new quantity called momentum. The momentum P of a moving body is defined as the product of its mass m and velocity v, that is P equal to mv. SI unit of momentum is kilogram meter per second. Also, it can be written as kg meter per second. Momentum has both magnitude and direction. Its direction is same as that of velocity. According to Newton's first law of motion, the application of an unbalanced force brings a change in the velocity of an object. Thus, the force can produce a change of momentum. Newton's second law of motion establishes a relationship between force and change in momentum. Second law of motion states that the rate of change of momentum of a body is directly proportional to the force acting on it and takes place in the same direction as the force. Newton's second law of motion also gives a relation between force and acceleration. This relation is F equal to ma. The unit of force is called Newton and its symbol is capital N. So, a force of 1 Newton will produce an acceleration of 1 meter per second square on an object of mass 1 kg. Some example of second law of motion from daily life we can discuss. In our everyday life, we see many applications of second law of motion. In many situations, we try to decrease or increase the rate of change of momentum by changing the time in which the change of momentum takes place. Let us consider some examples. Why does a person get hot when he falls on a cemented floor? Just before touching the floor, the person has some initial velocity, say u, which becomes 0 when he comes to rest. Thus, the momentum of the person becomes 0 within a very short time. As the rate of change of momentum is very high, so very large force is exerted on the person, thereby hurting him. On the other hand, if he falls on sand or husk or on a foam mattress, it does not get hot due to longer period of time in making momentum 0 and hence reduction of force. Now let us discuss Newton's third law of motion. You must have noticed that when a rubber balloon filled with air is released, the balloon moves opposite to the direction of the air coming out of it. Why does the balloon moves in a direction opposite to the direction in which the air escapes? Let us find out. You must have also noticed that when you jump from a boat to the river bank, the boat moves in the backward direction. Why does this happen? While jumping out of the boat, your foot exerts a backward force on the boat. This force is called action. At the same time, a force is exerted by the boat on your foot, which makes you move forward. This force is known as reaction. Remember that two bodies and two forces are involved in this problem. You push the boat backward and the boat pushes you forward. The two forces are equal in magnitude but opposite in direction. Let us consider the balloon problem again. In this case, the air coming out of the balloon exerts a force of reaction on the balloon and this force pushes the balloon backwards. Newton, in his third law of motion, stated a relation between action and reaction. According to this law, to every action there is an equal and opposite reaction. The action and reaction acts on two different bodies. If action and reaction are on the same body, they will constitute a balanced force and body will not move. There are three significant features of third law of motion. We cannot say which force out of the two forces is the force of action and which one is the force of reaction. They are interchangeable. Action and reaction always act on two different bodies. The force of reaction appears so long as the force of action acts. Therefore, these two forces are simultaneous. Remember, it is not necessary that the two bodies amongst which the forces of action and reaction act are in contact. They may be quite far from each other. For example, attraction or repulsion between two magnets can take place even without being in contact. The action and reaction forces enable us to swim. During swimming, we push the water in the backward direction with our hands and feet to move in forward direction. It is the reaction to this force that pushes us forward. It may be interesting for you to know that rockets and jet planes also work on the principle of action and reaction. In each of these, when the fuel burns, hot burning gases are ejected from the tail. The hot gases come out in the backward direction and the rocket of the jet plane moves in the forward direction. Now let us discuss conservation of momentum. According to this law, if two or more objects collide with each other, their total momentum remains conserved before and after the collision, provided there is no external forces acting on them. From the Newton's law of motion, we know that the rate of change of momentum is equal to the force. If P1 equal to initial momentum and P2 equal to final momentum after time t, then F equal to P2 minus P1 divided by t. Now, if F equal to 0, then we have P1 equal to P2, which shows that the momentum of a system remains unchanged or conserved if no force is acting on it. Now, let us come to the concept of friction. You might have noticed that a ball rolling along the ground stops after moving through some distance. Similarly, a moving car begins to slow down the instant its engine is switched off and finally it stops. Why does it happen? Let us find out. According to Newton's first law of motion, a moving body continues to move along a straight line unless an external force is applied on it. Is this external force slows down the motion of the ball or the car? Think. In fact, the ball or car is slowed down by a force called friction. Friction exists between the surface of all materials which are in contact with each other. The direction of the frictional force is always in a direction opposite to the motion. Now, try to analyze the forces acting on an object moving with a constant velocity. If an object is to move with a constant velocity, a force equal to the opposing force of friction must be applied. In that condition, the two forces are balanced forces. They exactly cancel one another and the net force on the body is 0. Hence, the acceleration produced in the body is 0 and the body maintains its velocity. It neither speeds up nor slows down. The resistive force before the body starts moving on a surface is called static friction. Once a body starts moving on a flat surface, the friction between them is called sliding or kinetic friction. You should remember that the sliding friction is slightly less than the static friction. You must have seen that it is easier to move a bicycle on a concrete road than on a rough road. Why is it so? Does friction depends upon the smoothness or the roughness of the surface? Let us find out. Set up an inclined plane on a table. Mark a line near the top edge of the inclined plane. Now hold a pencil shell on this line. Release the pencil shell. What do you observe? The shell moves down the inclined plane and continues to move for some distance on the table. Note down the distance up to which the shell moves on the table. Now place a glass sheet on the table. Again release the pencil shell from the line on the inclined plane and note the distance up to which the shell moves on the glass plate. Repeat this activity by spreading a uniform layer of sand on the table, in which case the distance covered by the pencil shell is maximum, in which case it is minimum. What do you conclude from this activity? You will find that the distance moved by the shell is maximum on the glass surface and minimum over the sand. The difference is due to the friction offered by the different type of surfaces. Smooth glass surface offers less friction compared to a rough sand bed. Thus, smoothness of the surfaces is one of the factors on which friction depends. You might have observed that more force is needed to move a heavy box than to move a lighter box on the same surface. It is so because the heavy box has greater normal reaction and hence greater frictional force. Thus, friction also depends upon the normal reaction. Now, what is the advantage and disadvantages of friction? This friction plays a very important role in our day-to-day life. It has several advantages as well as disadvantages. Have you ever walked on ice or a wet marble floor? You might have found that it is difficult to balance your body. The force of friction developed between the soles of your shoes and the ground helps us to move. Had there been no friction, walking or running would have been impossible. You can write with a pen on page or with a chalk on the blackboard due to friction. Buildings may be constructed only due to force of friction between different building materials. Tires of automobiles are treated to increase the friction between tires and surface of the road. Thus, the tires get better grip with the ground. The brakes applied in automobiles also work only due to friction. Can you think of some more examples from your daily life where friction is useful? Now let us discuss disadvantages of friction. Due to friction, a lot of energy is wasted in the form of heat that causes wear and tear of the moving parts of a machine. Friction also reduces efficiency of the machines as considerable amount of energy is wasted in overcoming friction. However, the efficiency of a machine can be increased by putting a suitable lubricant between its moving parts. In most of the machines, to reduce friction, ball bearings are used between the moving parts. By using the ball bearing, the sliding friction is replaced by rolling friction. As the rolling friction is less than the sliding friction, therefore, the friction between the moving parts is reduced. Friction also wears out the soles of shoes. You would have seen that the steps of foot-over bridge at railway stations also wear out due to friction. Now, let us discuss about thrust and pressure. Observe some bodies around you like table, desk, bucket full of water, etc. They press the floor with a force equal to their own weight. You know that weight is the force acting vertically downward. As the surface of the floor can be taken as horizontal, therefore, the force with which each of the above mentioned bodies presses the floor is directed perpendicular to the surface of floor. The force acting upon the surface of a body perpendicular to it is called thrust. Let us find out the effect of thrust acting on a surface. Take a small wooden board with 4 nails fixed at each corner. Fill a tray with sand to a depth of about 6 cm. Place the wooden board and sand with the nail heads downwards. Also put about 500 gram weight on the board. Observe the depth of the nails up to which they penetrate into the sand. Now place the wooden board on the sand with pointed side of the nails facing downward and put the same weight on the board as in the previous case. Again observe the depth of the nails up to which they penetrate up to the sand. In which of the above two cases the penetration is more? You will find that the penetration is more in the second case. Thus, the action of the given thrust depends on the area of the surface it acts upon. The smaller the area on which the force acts, the more evident is the result of its action. The thrust on a unit area is called pressure. Thus, pressure equal to thrust divided by area. The SI unit of pressure is Newton per meter square. This unit has also been given a specific name Pascal in honor of the scientist named Blaise Pascal. Equation shows that the same force acting on a smaller area exerts a larger pressure and a smaller pressure on a larger area. This is the reason why cutting tools like knives and axes always have sharp edges. In many cases, it is desirable to decrease pressure. In such cases, the area on which the thrust is acting should be increased. For example, foundation of buildings and dams are made on larger area. Similarly, trucks and vehicles used to carry heavy loads have much wider tires. Also, army tanks weighing more than 1,000 tons rests upon a continuous chain. Now, let us summarize what we have discussed today. Unbalanced forces acting on an object may change its state of rest or motion. Balanced forces do not change the state of rest or motion of an object. Forces can change the shape of the object on which they are applied. Inertia is the tendency of objects to stay at rest or to resist a change in their state of motion. Newton's first law of motion states that every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by some unbalanced force to change that state. The momentum of a body is the product of its mass and velocity. The SI unit of momentum is kg meter per second. Second law of motion states that the rate of change of momentum of a body is directly proportional to the force acting on it and takes place in the same direction as the force. The unit of force is Newton and its symbol is capital N. A force of 1 Newton will produce an acceleration of 1 meter per second square on an object of mass 1 kg. Newton's third law of motion states that to every action there is always an equal and opposite reaction. Action and reaction always act on two different bodies. Force of friction always opposes motion of bodies. Friction depends on the smoothness of surfaces in contact. It also depends upon the normal reaction. Rolling friction is less than the sliding friction. Force acting perpendicular to the surface of a body is called thrust. Thrust per unit area is called pressure. The SI unit of pressure is Newton per meter square. This unit is also known as Pascal. Thank you.